Today is our first exclusive Xdisp webinar. So what we will be covering is Xdisp theory and its use in industry, and this will help you appreciate and understand the next stage, where I set up a simple tunnel and excavation analysis. I set up a building damage and utility damage assessment, and I demonstrate the graphical input feature. And by demonstrating the graphical input feature, you can see how quickly you can set up quite a complex model. So hopefully by the end of the webinar, the final objective will be you have a very good understanding of what Xdisp can do, and you're able to go to the right place to learn much more and use it proficiently. In terms of an introduction, I'm just going to briefly run through the analysis. Xdisp calculates ground movements due to excavation. So these excavations could be due to tunneling, but not hard rock tunneling. We've also considered retained cuts, for example, and circular shafts, and also mined excavations. So Xdisp can give you surface displacements and subsurface displacements. In terms of the analysis methods, today I'm going to mainly cover the tunnel-induced ground movements and excavation-induced ground movements, but I'll touch upon the mine-induced ground movements and where you can go to find out more about it. In terms of the tunnel-induced ground movements, it's generally based on empirical data, so it's not the same as finite element analysis. We look at the distribution over a tunnel, so as you can see, we've got a settlement trough directly above the tunnel, and we've got settlement along the tunnel. But it does expire that actually the normal distribution relationship shows a close match to tunneling-induced case study movements at ground and at subsurface levels, and this is backed up by a number of publications. I've just included the Addenbrooke and Potts publication here from St James's Park, but there have been other studies done. In terms of the actual analysis, as I mentioned, it's empirically based. So if it was analytically based, if you need to do a finite element analysis, you would have to understand the soil properties, the strengths, the stiffnesses, and various other things. But for Xdisp, you just really need to know your volume loss and your trough width parameter, and then you get complete three-dimensional behavior of the ground due to tunneling. So it's quite a powerful program based on very simple principles. So in terms of the volume loss, we've got what volume loss is the ratio of additional volume of excavated ground over the theoretical volume of the tunnel. So you might be wondering, how am I going to get this value? Well, firstly, volume loss depends on many factors. So tunneling methods, ground and groundwater conditions, flexibility of lining, all sorts of things really. So many authors have provided guidance on volume loss, and so you can have a look at case studies. There's also an empirical approach considering C over D values and P over D values. So I suggest you have a look at Macklin to get volume loss properties from there. The actual impact of volume loss, or the K value, can be shown here. So as you can see for sand, we've got typically a K of 0.3. So we've got a higher settlement closer to the tunnel, but the actual area of influence of settlement is much less. So say, for example, I had a building here. It's probably better if I'm lying on sand than if I was in clay, for example. Typically, clay has a K of 0.5, and as you can see, we've got a lower settlement directly above the tunnel, but further away from the tunnel, there's a higher zone of influence. So as you can see, the K value affects the type of trough that you've got directly above the tunnel. In terms of the trough width parameter, there are a number of relationships proposed. We've got I equals K over Z naught, which is often used. So you can use, for example, the O'Reilly-New-Boscawen relationships for surface displacements, and they're available directly within Xdisp. And if you want to consider subsurface displacements, Merritt, and New and Bowers are also available. All of this is really shown in a lot of detail in the manual, so I suggest you have a look at it before deciding what you use. In terms of mining-induced ground movements, the method is proposed by Wren et al., and it can define surface displacements. Again, this is given in more detail in the manual. I'm not going to go through it in the demo today, so if you are interested, please either contact us or have a look at the manual and we can help you with it. For excavation-induced ground movements, there are two different types of ground movements that we can consider. One is at the surface. So you've got this excavation here, which is this cube shown here. And this red rectangle is the surface displacements, the displacements radiating out from the excavation. So for example, Sirius C580 published a number of curves for stiff clay, effectively London clay, and those are the surface displacement curves there. However, if you're not in London clay or if you're not in stiff clay, what you can do is there are a lot of empirical studies out there which give similar curves, and so you can input that into Xdisp. But what happens when you've got displacements below this area? So what do you do for subsurface displacements? Well, initially, what happened was Xdisp took your surface curve and pulled it down to 0 at the base of excavation. So you have this kind of line interpolation effectively. But if you look at the graph here, you can see that actually that's not very realistic. So these curves are actually taken from a 3D FE analysis, and you can see that actually there is displacement at the base of the excavation. So how are you going to address that? Well, now what Xdisp does, it allows you to input a curve, and we're going to be doing that in the demonstration. And you can base this curve either on an FE analysis, and there's guidance given on the website as to how to derive it from a 2D FE analysis. Or what you could do is you could take settlement results from an excavation in a similar type of soil, input it in there, and then you can combine those results with a number of different excavations and tunnels to get your 3D ground settlement or ground settlement profile. Another thing that's considered now is corner stiffening. So initially what Xdisp did was it took this excavation and it just radiated the settlement, that surface settlement around the excavation. So as you can see, this is just going directly around the corners. But that's not actually realistic. What happens is the corners actually stiffen the settlement profile, and what you'll happen to have is actually a lower settlement around here. So Fuentes and Devrand published a paper which showed by how much there would be a factor of stiffening and how to calculate this, and that's what's been incorporated into Xdisp. The values are already in there from the Fuentes and Devrand paper based on case studies, but if you've got a different type of soil surface, for example, you're looking at something slightly different, then what you can do is you can actually take it from your own case studies or own empirical data. To better understand the way Xdisp works, really when we go into the demo you'll really see this, but the best thing for me to do is actually just quickly run through the inputs. So you've got the tunnel and mine type, so you've got to tell the program what type of problem you've got. You've also got to tell the program where do you want to calculate settlements. Do you want to calculate it at along a line, just at a surface or subsurface grid, or a point? And also, where are your actual entities? Where's your tunnel? Where's your wall installation excavation? Where's your mine? And finally, Xdisp has recently been updated to consider buildings and utility damage. So if you are considering these, where are your buildings and where are your utilities? Just in terms of shortcuts, I am going to run through this in the demo, but what you could do, for example, is you have an option of inputting defaults within Xdisp or within any kind of program table. As you can see, we've got these defaults in here, and you can change it yourself. And then if you tab through the defaults, you just take if you tab through the default in a cell, you take the value from that cell, and it comes through into the cell. So it helps you from having to type things in. We've also got the equals button to copy from the cell above, and if you type in equals twice, then you can copy the line above. I'll be showing you how this works. Often in Xdisp you have quite complicated files, so you might have a number of loads, or you might even have a number, for example, of lines to make up a tunnel. So Control-G will let you type in a line to go to, so that'll save you a lot of time and trouble if you know you're consistently going to a certain tunnel. And if you right-click, you've got a number of options within the table. Modify is probably the most useful. So say, for example, I wanted to factor all my Young's moduluses by a certain value. I could just right-click and go to Modify, and that would do it for me. So there are ways, even though you can set up a very complex file, there are ways to simplify down any editing that you have. And in terms of the outputs, Xdisp has been developed numerous times to produce very attractive outputs really for reports. So as you can see, we've got a very good 3D graphical output which shows effectively what's happening. And this 3D graphics output will really show, for example, a client or during a presentation or in a report how displacements are occurring in relation to your tunnels and excavations. In terms of your actual displacements, you could pick a line and plot the displacements, and you've also got your building damage interaction chart. So say, for example, for a specific building, you can see where your building lies in terms of damage category. So all of these features have been very well developed for big projects such as Crossrail, for example, where they've been used time and time again. So quickly, I'm going to just show you a case study to show you how the program's been used. One case study is the Copenhagen Metro, which is a 15.5 kilometer metro line with a number of underground stations. This project was a specific challenge because in Copenhagen you've got a number of historical buildings on wooden piles, and you've also got groundwater issues. So a settlement limiting settlement was really key to this specific project. And in this particular case, Xdisp was used to plot this tunnel and look at the kind of settlements you've got around it, pick up the key buildings, and then carry out building damage assessments. So in a little bit more detail, what we did was, or what the Arab engineers did, was that they carried out a general Xdisp analysis. So they would have plotted some contours, for example, and found areas where you've got displacement more than 5 mil, or where the predicted slope is more than 1 in 500. So within those specific shaded areas, what would happen then is all the buildings would be represented in the building as buildings within Xdisp, and building damage interaction charts will be plotted. So based on these settlements and these gradients, we would plot a building damage interaction chart. And if the building was shown to be in a high category of damage, then a further evaluation would be done, maybe even 3D FE. So that just gives you an idea of the kind of process that's involved with these big projects. So I'm just going to run through a very simple analysis first, just to show you how to start up an analysis and where to go with that. I'll start up Xdisp new. Here's the Xdisp interface as you start up. Click on New, and I'm in the title section here. It's important that you actually do put in a little bit of information here, especially if you're running a number of different analyses. The reason is that this actually shows in the tabular and graphical outputs at the end. So if you're running checking, for example, or if you're producing these for reports, this kind of information is critical. You can change the units. There are a number of options here, but I'm happy with SI. The problem type is tunneling and excavation in this case. So now, where do I need to, what area am I interested in with regards to displacements? So if I go into the presentation, as you can see here, I want to plot this specific grid. So this corner here is at 10, 0. It's 190 meters along the x-axis and 110 meters along the y-axis. So there are two ways that you could plot this. You could basically draw a line here along the y-axis, along the y-axis, and extrude it out towards the x-axis. Or I could draw a line along the x-axis and extrude it out along the y-axis. And that's exactly what I'm going to do. So I'm going to draw this line here along the x-axis and extrude it out along the y-axis. And this is called the global y direction. And that's what's going to be done within this specific problem here. So I'm going to type in grid, take grid 1. I'm going to choose the global y. My first point is going to be at 10, 0, 100, because that's the surface ground level. So as you can see, you can actually work in meters OD with this. Okay, so it's 200. There's no y. Because it's along the x-axis, and it's 100 again. Now the number of intervals is very important. You need to have enough calculation intervals to be meaningful, and I will go into this in a little bit more detail later on. So as you can see, the extrusion depth is 110. So the extrusion depth is along the y-axis, and surface, so that's fine. So this is a surface grid, and the extrusion depth is 110. So if I go back into the presentation here, you can see it's extruded 110 meters, and the length along the line is 190 meters. So that's how it's been plotted, and hopefully that's explained a little bit for you. So Xdisp has a really good feature in terms of copying and pasting. So it's very easy to copy and paste from Excel or copy and paste from another Excel Xdisp table. So say, for example, you want to create numerous files. Instead of playing around with one file and making mistakes, you can actually have your base data in an Excel file and other people can start working on it and creating things. So as you can see, I've set up two grids, one at 100 meters and one at 90 meters, so one at 10 meters below ground level. I've also got a number of lines set up. So to check this, the best thing to do is double click on 3D graphics and have a look and see. As you can see, I can easily see my two grids here. If I go to the wizard icon or right click and go to wizard, I can switch off the grids and just check my lines. And as you can see, the lines are pretty much as I would expect. So this is a nice thing to do regularly because it means that you can check what's happening, where are your lines in relation to your tunnels, have you put them in the right place, and it's definitely worth doing. In terms of tunnels, I've actually got the tunnel data again, so I'm going to copy this and I'm going to paste it in here. So as you can see, we've got the diameter here, the start point and the end point. If you have a curving tunnel or a rather complex tunnel, the best thing to do is plot it as a number of different tunnels. And you can simplify this further with a CAD import. So I'll discuss how you should do this. We've got ground loss, which is 1.5. I've derived the K user specified, so 0.5, so we're effectively in clay here. And we've also got subsurface displacement calculations. We've got K values for the subsurface because we are actually considering the subsurface analysis here. Okay, so I'm going to go into the embedded wall excavations here. I'm going to put the curve in here. So as I'm considering a subsurface analysis, I don't have a subsurface curve, so I've actually got to put a new curve in. And I'm going to copy and paste some points from Excel. These points are taken from 3D FE analysis, but to be honest, you can easily do a 2D FE analysis, or alternatively, you could just take it from some site readings of settlements around an excavation. Okay, sorry. Okay, so it's important that you click on apply to make sure that it's all saved, and then click on view graph. And if I zoom out of this, you can see that going out from the excavation, you've got, as you go down, you've got varying settlement profiles, and as you go out, you've got different settlement profiles as well. So it gives you an idea of how it works and what's happening. Okay, so now if I go into vertical, again, I'm going to insert a new. Okay. I'm going to go in here again. I'm going to copy and paste. The details of the kind of points that you need and everything is available on in the manual. So do have a look to better understand how to work this. And also there's an excerpt, an extra PDF which is available in the tutorial file, which again runs through what you need to do. Okay, so that's been input and that's working fine. So now we've got our curves. We can go into excavation. I could put a shaft in if I wanted to, but I'm actually going to go here for a polygonal excavation. So I'm going to new excavation. Okay, the surface level for me is 100 meters OD, and my values are, I'm just going to put the point in for the excavation. I'm not going to have it stiffened in this case, but as you can see, the default values are here from the Ralph Fuentes paper, Ralph Fuentes and Mike Deverin's paper. I'm going to type in equals and just change on values because it's just much quicker to do this. As you can see, I'm typing in equals, copying from above. I'm going to change this to 70, and again equals, and I'm going to change this to 50. Okay, so as you can see, I've got my excavation there. I now need to assign the excavation ground movement curves. So vertical ground movement and horizontal ground movement, and I'm just going to copy from above. So I'm just using the equals button to do that very quickly and very easily. So as you can see, these shortcuts just make things much easier, especially if you're doing this many times. Okay, so to be honest, we're good to go now. So if I look at this, it's everything we want it to be. And I think we're ready to run our analysis. Analyze. Okay, we'll just have a look at the results. And as you can see, we've got a number of displacements because I put a number of points in the grid. That's great. These can be exported if you want to analyze it in more detail into a tabular output. So as you can see, I can put it into a CSV, and the tabular output could be put into an Excel file, for example, if I wanted to. But I'm actually interested in actually looking at the results in plan. So for example, if I click on the Fill Contours button, I can look at the contours for my grid at surface level. I can go down a grid as I'm clicking on this button here, and I can look at the contours at 10 meters below ground level. But I'd also like to look at maybe a few line graphs to see the settlements as you go along a line. Maybe these lines might represent a utility or another tunnel or something of interest. I'm going to click on that, and as you can see, I've got the vertical displacements and the horizontal displacements there. So very quickly, a lot is produced by this program. If I right click, I can also change the chart style. I can export this and save it as a JPEG or anything along those lines. But if I wanted to print this, so you can see the details here are showing from the titles area. But you might also want to put your company details and everything in there. And this is all possible by the Tools Preferences option. So you can change that if you so wish. And that will help you with your printouts. So that's the plan covered, and hopefully you have a good understanding of how to do that, and you're a bit more confident and proficient in doing so. It's also worth pointing out that if you wanted to pick up a contour on a specific point, you can actually click on Annotate the Contours, and it can pick up the actual displacement at that point. In terms of the 3D graphics, you might be wondering, how am I going to use this to show anything with regards to settlements? Well, if you right click on the settings wizard and click on wireframe, you can actually shade these out a little bit. If I go to displacements and have a look at the deflected line, I can look at how displacements are occurring along the lines and how they're occurring in relation to the excavation. So that's a handy thing to do. Maybe I want to actually have a look at the grid, at either the fill contour, or I can look at the line contour. I can also, by right-clicking, going to Settings Wizard, I can maybe change the contour interval and have a look at the contours like that. So there are a number of options available, and maybe I just want to maybe show a client the deflector shape in relation to our problem. And as you can see, in relation to the tunnel and excavation, you can see the deflector shape quite nicely. So depending on who's checking it and who you're showing, you have a number of options with the graphical output, and you can print this out and show it in your reports. So that's really the tunnel and excavation example covered. In terms of further analysis, you might find that you want to do a building damage assessment or a utility damage assessment, or you might want to use some of the more advanced features of Xdisp. So I'm going to start with building damage and defining what it is and trying to help you understand what the building damage assessment is. To start off with, the building damage assessment looks at a number of categories of damage. So you start off with visual appearance, cracks and aesthetics. It goes on to the serviceability of the function of the building and the stability of the building itself. So Berland proposed a very good category system, and these categories show category of damage from 0, which is negligible, to 5, which is very severe. So in terms of the description or the view, we can look at the crack widths, or for example, with a negligible category of damage, you've got a hairline crack, but at a very severe category of damage, you've got a massive crack, and it may even require rebuilding. He's also looked at the performance of the building in terms of representing it as an elastic beam and looking at the limiting tensile strain. So, for example, for a lower strain, it's negligible damage. When you've got very large strains, then you should be concerned. So, in terms of the assessment methodology, it's been proposed in Assyria Guide, which is based on the Jubilee Line extension, that you have a preliminary assessment, which is a stage 1 assessment. This was covered also in the case study. So in this preliminary assessment, you look at where you've got high settlements or where you've got high gradients of settlements. And then those specific areas, you go on to the second stage of assessment, which is the building damage assessment. And that's where you carry out these specific assessments and you look at the category of damage. And if you find that the category of damage is very high, maybe you're reaching 3, 4, or 5 in terms of Berlin's categories, then you go into a detailed evaluation and maybe you carry out an FE analysis, look at a 3D FE analysis, look at maybe a GSA analysis of the building, various other things could be available. In terms of the assessment method, what we're mainly concerned with from that previous guide is the building damage assessment, which is stage 2, which idealizes the facade or wall of a building as a deep elastic beam. Now, this is shown to actually be reasonable for a brick masonry structure, and examples of use for reinforced concrete structures are also included in that guide that I mentioned previously. So firstly, if we imagine that our building is a beam, and very simply, for example, if I put a tunnel over here, you would have this kind of settlement profile, which is shown by this dotted line, and which I'm highlighting here. Above that settlement profile for this solid line, you would have a profile of horizontal strain. Okay, and so for that profile of horizontal strain, we can then find out where the beam is in tension or compression, and whether the beam is hogging or sagging. And the reason that this is important for you to understand is because every segment of either hogging or sagging, Xdisp splits within the beam. So basically, if you look at this simple beam here, the beam will be split into 3 segments. And for each of these segments, for this hogging segment, sagging segment, and hogging segment, it would then go and calculate the category of strain, and it would plot a graph for you. So it's important that you understand how it's been split up and why it's been split up. And as you can imagine, if you've got a number of buildings and it's split it up into a number of segments, you've got a multitude of charts, and you've also got a multitude of displacement graphs and various other things. So it's quite a lot for you to get your head around. So instead of having to print out everything separately and think what's important and where do I go to and how, Xdisp does this for you. So it actually exports a folder with all these different printouts, with all the different tabular outputs and various things, so that you could have one place where you've got everything and you don't need to do it by hand, and it does it very quickly for you. So that's the specific building damage assessment covered, and that's what I'm going to be presenting to you today. But it is worth just touching upon the generic building damage assessment as well. So what a generic building damage assessment is say I plotted this line, and this is where I'm carrying out my specific building damage assessment. Maybe I was asked by a client, okay, fine, you've got this building, you've put it in, but actually I want to know whether, if I had an area, which is the building which would be worse affected. And you can actually carry this out with a generic building damage assessment by plotting a polyline, which I've got here, and then within the polyline, you have a number of transects. So I've got 3 transects here, but you could have a number. And for each of those transects, what Xdisp will do is carry out a building damage assessment and maybe calculate the worst case value, say for horizontal strain or various other things. And so if I calculated the best case value for strain, then I could see which building would be the most affected. So that's how the generic building damage assessment works. And if you want to do that in more detail, there's a detailed cover in the tutorial manual. So now we'll go through the run through. I'm going to do a specific building damage assessment. What I'm going to do is I'm just going to open a base file. And what this base file has is it basically has the displacement data pre-inputted, and it's got the tunnels in there as well. And the polyline is there, so if I wanted to set up a generic problem, I could do. So this is the base file that's available to you with the tutorial on our website as well. So please feel free to look at that in your own time. So I'm just going to take out these things and only look at building damage assessment, starting off with damage category of strains. As you can see here, we've got the Berlin limits, but maybe you want to input something in country specific or very specific to your project. You could do so if you wished. In terms of the specific structure, I'm going to tab with my defaults. So building 1 is fine, substructure 1 is fine, my building is at the surface, my line length, this structure is effectively lying on a displacement line. So if I go to displacement data, you can see that this displacement line surface, which is what I've called it, is what it's sitting on. So so it's sitting at ground level. In terms of the start distance along the line, I want the building to go along the whole line, so it's 100 meters. Vertical offset. So what vertical offset is 0 means it's at the level of your displacement line, but maybe you've got basement levels at minus 5.5 and minus 11 meters OD. If you put them in there, what Xdisp will do is it will calculate the building damage interaction charts for those levels as well. So that's quite handy. Vertical displacement sensitivity pertains to how the program splits subsections of hogging and sagging. So you can have a look at that in your own time, but 0.1 is a reasonable value. I'm choosing the Berlin strain limits. In terms of Poisson's ratio and E over G values, I'm going to tab this. 2.6 is fine, 10 is fine. Again, I'm tabbing, and I've got default properties, so I'm tabbing. So the Poisson's ratio, E over G, and height are values for the beam and building. Xdisp calculates, for example, values for the beam, the moment of area, and everything for you. But if you wanted to input it in yourself, you could do. So there is an option to input it in manually. Okay, so I think we're good to go. We've set up everything. It seems to be working just fine. And as you can see, there's not much to do. Run that. I'm just going to show the building damage output so that you can see the way that works. So as you can see, for the building, we've got the displacements along the lines. And this shows at 0 meters, minus 5.5 meters, and minus 11 meters, the different results for these lines. So this is basically picking out that specific line, which is shown here. So this is just looking at the specific building. And for that specific building at different levels, it's split up that beam into sections of hogging and sagging. And if you wanted to, you could even combine these sections depending on the actual profile of tensile strain or on the profile of strain. And then so if I look at this at minus 11 meters for segment 10, I've got a severe damage category. So it would be interesting to actually go and look at the chart and maybe print it out for a customer or a client. So I'm just going to go into plan. I'm going to click on the graph icon, and I'm also going to choose a specific structure for building damage so that picks up the building damage graph. I'm going to go to the building instead of looking at the displacement lines. I want to look at minus 11 meters because I remembered that was the area where we had the severe damage. I want to look at the building damage interaction chart, and segment 10 was again where we've got severe damage showing, and lo and behold, there you go. You can see that this is where we've got severe damage showing, and if I printed out this chart, I could show it to a client and show them that this building was probably of concern at that specific level and that we would have to do something about it. So as you can see, I've quickly set up a problem, and I've got results. And Xdisp has a lot of options for you. It is probably worth showing you actually the exporting of building damage assessment data as well. So if I click on export and building damage assessment data, I can export this whole file, well, this graph and a number of other graphs as well. So if I go into the file here, this is for one building, but for example, if I had a multitude of buildings, they would all show substructure 1, but if I had a number of substructures, again, they would show. And as you can see, we can pick up any building damage interaction charts for a number of offsets. So if I want to pick up the same chart, there you go. I've got a JPEG of it, and I can print it out or send it to a client. Okay, so back to the presentation. We've gone through the specific building damage assessment. It's now worth going through the utility damage assessment. So very recently, the developers had added this feature. Previously, people went to these particular displacement lines, they picked out the utility displacements, and they had to carry out all the calculations themselves. But now, if you input your utility dimensions, Xdisp will carry out all the calculations for you. So it's another feature to make things much quicker and easier. So we calculate strain, pull out, and joint rotation based on the displacements and dimensions. The acceptance criteria needs to be set by the user, but if you're setting an acceptance criteria very regularly, you could just put it in the defaults. Again, generic utility damage assessments are available, so instead of picking one specific line, if you plot a polyline with a number of transects, you could look at, for example, where the worst rotation would be in these polylines, and maybe decide to put a utility in that specific area. So this would help you plan if you're planning to install utilities, or your utilities put in just before your tunnels and various other things. So again, it's a very useful feature. So why don't we again go into Xdisp and run up a specific utility damage assessment. So I'm just going to start off with this base file here again. I think I'll delete the structure. Okay, and I'm going to close up building damage assessment and now input utility data instead. So with the same problem, with the same two tunnels, I'm going to input in a utility which lies along that displacement line. So for the utility, I'll have the dimension being 1219 mil, internal diameter of, I'll just tab utility dimension, so dimension 1219 mil, and wall thickness is 15. Okay, so we put the name and the diameter and thickness in. We now need to specify our acceptance criteria. I'm going to type in verified clay. I'm going to check on the tension, choose 100, check on the compression, default 1200, check on the rotation, 0.3 for the rotation threshold, check on the limit, 0.5. So every time I say check, it means that I'm going to say that, for example, at this point, at this threshold, the utility will fail if it reaches this value. If I said no, for example, it wouldn't check it. It means that, you know, it wouldn't fail and it will only go to the limit. So it's entirely up to you how you want to set that up. So threshold 3.5. I'm going to say no for this. And I'm going to check on a limit though of 400. So that's the default. So I'm happy to go with that. I'm going to have the Young's modulus of the pipe. Poisson's ratio is 0.3. Now these values, I'm not going into too much detail as to what these values are, because all the information is available through the help area, either in PDF or looking at Xdisp help. You can also just have a look at the technical FAQs and tutorials if you need to have a look at any videos or demonstrations. So do check the help section to see whether you've got everything in place, and also to help you with definitions of anything in a table, for example. So I've got my acceptance criteria, I've got the dimensions of the utility, and now I need to input the utility details. So happy to go utility 1, sub-utility 1. I'm going to go with dimension 1, verify clay. I'm just tabbing through because it's already in the defaults. Displacement line, I'm not going to choose surface because my utility is below ground level, so I'm going to choose mid-upper. So if I go and check in displacement data, the line mid-upper is a minus 5.5 meters. That's fine. That's what I want it to be. So my utility doesn't go completely along the displacement line. It actually only goes 50 meters along. The pipe segment is important because it's used for calculating joint and rotation values, and assessment interval 1. So everything's input, quick and easy. Run the analysis. Okay. So as you can see in plan, I can pick up the utility here. I can click on this. So I put the tabular out for the first. I'll click on utility damage so you can see what's happening. So if I clicked on tabular and I looked at the utility damage results only. As you can see, everything's okay in terms of my pull-out check, and pipe strain check is not a concern. Everything's okay at the rotation limit, but at the threshold values, it's failing. So overall, it's showing that this is failing. So it would be interesting to have a look at the rotation graphs and threshold. So if I go into plan, I've got my utility. I've clicked on utility. I've clicked on my line graph. I click on here and I pick my utility. Okay, I want to look at rotation because I know that's where it's failing. I bring up this graph, and as you can see, it's failing at the threshold. So this graph is showing that if I want to increase the threshold or alternatively change the configuration of my tunnels or my utility, I could do so and then produce this graph again. So as you can see, you get quite visual results very quickly and very easily. So that's really given you a good idea of how the building damage assessment and utility damage assessment work. I suggest you look at the tutorial manual and try them out, and also try out the general utility and building damage assessments. In terms of other developments, I mean, Xdisp is used on major projects around the world, and as you can see, I mean, if you've got a number of station boxes and shafts, if you've got a number of tunnels and buildings, it's quite onerous to input everything in by hand or even through Excel. So actually you can import everything from DXF. So if, for example, I ascertain a layer, for example, to the lines which are associated with buildings, the lines which are associated with tunnels, and the lines which are associated with excavations. If I import that into Xdisp, immediately I would produce an image like this, and then it's up to me to input the tunnel properties and various other things. But at least in terms of the dimensions and all the coordinates, everything's inputted very quickly and easily. We could also input the background. So you might be wondering why the background's important. Well, say for example you're showing your graphical outputs. If you've got the background there, it's quite nice to show in relation to the map. But another reason that importing the DXF background is important is actually in terms of graphical inputs. So Xdisp has a very recent feature whereby you can input, for example, a CAD drawing or CAD background, and then you can start sculpting or drawing the tunnels, drawing your grids, drawing your excavations. And so that's actually quite a powerful feature, and it allows you to set up something which can be quite complicated very quickly. So I'm actually going to show you how to do this by setting up a brand new file. And as you can see, we're starting with very little. The problem type is tunneling and excavation. I'm going to go to File, Import the DXF file. I've got a simple site plan, so that's imported. If I go into 3D graphics and look at that, as you can see, we can see the site plan here. So I know that I'm excavating in this specific area here, and I've got a tunnel maybe going along this road. So why don't I input that in? So I'm going to go to Input Output and click on this icon here, if you look to the left-hand side. And I'm going to put in some grids. I'm going to put a grid in at surface level, which is 0 meters OD, with the standard grid layout. Okay, I'm also going to put a grid in at -5 meters OD, which is where I'm going to be drawing my tunnel with the same grid layout. Okay, so I'm now going to start drawing the tunnel. I'll click on the Add Tunnel icon. I'm going to click on my start point, double click on my end point. I've got a tunnel with a diameter of 5 meters. I'm mainly considering surface displacements. I'm happy for them to be calculated with O'Reilly and New. I know my soils are cohesive, so I'm good with that. That's great. So I've got my tunnel now, and if I go into the table, it's already inputted in there. So as you can imagine, if I've got a curvy tunnel or something more complex, that's actually a really handy thing to do, especially if I wanted some quick results. So I've got the tunnel in there. Again, I'm going to click on the Input Output. I want to also put an excavation in there. So I can add here a shaft or a circular excavation, but I'm going to go for a polygonal excavation. I'm going to add that. I need to go to the right grid though, because currently I'm at -5 meters OD. Go to grid plane 1. I'm going to add my excavation. I'm going to draw it and double click on my last point. So that looks great, that's fine, but I need to assign a ground movement curve to it. I'm going to go with the Sirius C580 curve. So all it tells me here is that if you have a Sirius C580 curve for the vertical ground movement curve, you have to have the associating horizontal ground movement curve as well. So it's just doing the work for me really, and just correcting me just in case I make a mistake. And I'm going to press equals again, copy the above cell. Everything's there, the surface level is 0 meters, that's fine. Okay, so I've got my tunnel and excavation, but then how about my displacement points? I need to know where the settlements should be calculated. I need to specify that. So I'm going to add the displacement grid first. I'm going to choose a grid around the excavation, because that's what I'm particularly interested in. There you go. So I've got the displacement grid at surface level. It's important that I select the number of extrusion, number of intervals, because these are the points where all the settlements will be calculated. So for example here, if I put 200 or something very, very small, I would get a very fine grid, but the problem would be then that it takes longer to calculate and analyze. And say, for example, I chose a massive grid around all of the tunnel and the excavation, then if I had a number of intervals across that, it would be even more onerous. So it is important that you choose the location and the number of intervals carefully. I'm going to choose around 30 intervals here. The reason being that I need enough intervals to show a fine grid, but I don't want too many. So if I click OK on this, as you can see, we've got a number of points around the actual excavation, and this should pick up settlements reasonably well. I also want to add a displacement line, and say I'll add that displacement line at the surface. I'm going to add the line running from here to here to just give me an idea of what's happening with the tunnel itself and with the excavation. So I've got the displacement line here. I'm just going to start with 2 points and just show you the effect of the number of intervals. Okay, so good to analyze, run the analysis, excellent. Okay, if I look at this in plan, if I plot the contours, great, it's given me good results. I can see clearly what's happening due to this excavation, and it's pretty much as I would expect. But if I zoom out, so I click on the unzoom button, if I click on graphs and click on this line, these results seem quite strange. It's not really picking up anything around the tunnel area, which would be around here. It's not picking up anything around the excavation. And the reason is, for this point, we've not actually chosen enough intervals. It is important that you choose the right number of intervals. So here I'm going to maybe go up to around 60. So then I know it's going to pick some points around the tunnel and around the excavation very well. I'm going to run the analysis again. And now if I go into plan and I look at that, if I click on the line graph and click on there, you can see much more clearly that kind of displacements we're getting around the tunnels and around the either side of the excavation, and it is pretty much as we would expect it to be. So as you can see, it's very important that you plot everything carefully, but at the same time, using the graphical inputs makes things so much quicker and so much easier. And if you wanted to just do a quick check, even sit down with your client and do it, then you could do using this graphical input feature. So that brings me to the end really of the demonstration side of things. In terms of Xdisp and PDisp developments, we've recently combined Xdisp and PDisp, so we allow the user to actually look at the displacements due to loading and the displacements due to ground movement, and you can actually import those displacements from PDisp into Xdisp and get a very powerful 3D model. So if you compare this with something like 3D FE, for example, you can get a number of results out very quickly, and obviously at a much lower cost than using 2D FE or 3D FE. This was an analysis done about 2 years ago, a year ago now, within Arup, and they showed the kind of time it takes to set up a 2D FE or 3D FE analysis. and Xdisp and PDisp give you a 3D result much more quickly and quite efficiently. So that's really a good summary of what Xdisp does. In terms of the objectives, I feel that now you should appreciate what Xdisp does, understand theory well, understand its use in industry. I've set up a simple tunnel excavation analysis, so you should see how that works. We set up a simple building damage and utility damage assessment, so hopefully you can see how powerful a feature that is. I've demonstrated the graphical input feature, where I set up a problem very quickly, and as you can see, you can set up something much more complex, almost as quickly. So we've run through our objectives, but really at the end of this demonstration, you should understand Xdisp reasonably well. You should be able to approach Xdisp, or at least go into the tutorial manual and use that with confidence. So tutorial manual is available from the website. So if you go onto the product page, if you look at supports and tutorials, you can download the manual from there. You can also have a look at our online training movies, and our frequently asked questions and the manual itself. Please do contact us if you have any questions. There are much more advanced things that Xdisp can do. So if you contact us via email or call us, then we're happy to help. It's also worth noting that at the bottom of our website, there's the YouTube page. If you click on the YouTube page and type in Xdisp, then you can pick up all the tutorials and all the previous webinars on Xdisp, and really get a good understanding of how it works and what's going on there. So I just want to say thank you everyone for your time. I hope this presentation has been useful, and I am looking forward to hearing from all of you with any of your questions.